Welcome back to Arxflix. Today, we're exploring a cutting-edge paper titled FusionFrames: Efficient Architectural Aspects for Text-to-Video Generation Pipeline. This research introduces a new two-stage latent diffusion text-to-video generation architecture based on text-to-image diffusion models. Here's a visual representation of the FusionFrames pipeline. The first stage synthesizes keyframes to figure out the storyline. The second stage interpolates additional frames to smooth the movements. Let's delve into the specifics of this innovative approach. Video synthesis methods have just started to develop and are confronted with several challenges. Training and inference are computationally expensive and require large, high-quality datasets. Moreover, video generation demands not only visual quality but also semantic coherence and smooth object transitions across frames. Temporal information is essential for achieving high-quality video generation. Typically, temporal information in diffusion models is integrated through temporal convolutional or attention layers. This allows for leveraging pre-trained text-to-image models to reduce the necessity for extensive text-video datasets. FusionFrames adopts a two-stage pipeline. In the keyframe generation stage, the focus is on generating the main storyline keyframes. The interpolation stage then focuses on creating smooth transitions of movements by adding extra frames between the keyframes. The keyframes generation uses a pre-trained latent diffusion text-to-image model. The spatial layers of the keyframe generation model are initialized with pre-trained weights from the T to I model. This approach includes both temporal layers of convolutions and separate temporal blocks. In this diagram, we see two approaches: mixed spatial temporal layers in one block and separate temporal blocks. Separate temporal blocks prove to significantly improve video quality, as supported by various quality metrics and human evaluations. In the interpolation stage, FusionFrames predicts groups of frames together to reduce computational costs and enhance frame quality. Specifically, the model predicts 3 interpolated frames between each pair of keyframes. Here's a summary of the primary changes made to the T to I architecture for frame interpolation. Recognizing the importance of efficient frame interpolation, FusionFrames optimizes its architecture to run 3 times faster than traditional methods while maintaining high fidelity. Let's look at how FusionFrames performed. The research shows that separate temporal blocks significantly enhanced video quality compared to mixed spatial temporal blocks. The keyframes provide a clear storyline, and the interpolated frames ensure smooth transitions, enhancing the video's realism and aestheticism. This bar chart shows a human evaluation study comparing different models. The study indicates a strong preference for videos generated using temporal blocks over those using mixed temporal layers. FusionFrames achieves top 2 scores overall and top among open-source solutions, with CELAPSM at 0.2976 and FVED at 433.054. These scores show that FusionFrames is a highly competitive text-to-video generation model. The efficient interpolation architecture also stands out by producing high-quality interpolations and reducing runtime significantly. This graph compares the running times of different interpolation architectures. FusionFrames' new interpolation method is more efficient, cutting running time to less than 1/3 compared to traditional methods. To sum up, FusionFrames represents a major advancement in text-to-video generation by efficiently leveraging latent diffusion models and optimizing temporal information processing. These innovations result in high-quality, realistic videos with smooth transitions. Check out the full paper for more details and code on their GitHub page. Thanks for watching Arxflix, and as always, stay tuned for more exciting research summaries. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.